All right, and the last question in section 13.3 is number 9, and it says to find the inverse of each function. So part A says f of x equals 2x. And so to set a problem up like this, I'm going to start by saying for my function f, the relationship between the input x and the output y is y equals 2x. So then what is the inverse going to do? Well, it's going to just swap the role of input and output. So in other words, I'm going to get that x is equal to 2y. Okay, so now let's go ahead and solve this equation for y, and I can do that by just dividing both sides by 2. And now what I'm going to do is write my final answer in function notation. So in other words, this y output for the inverse can be written as f inverse of x, and this is equal to, well, x over 2 in this case. And so this would be the equation of the inverse. Okay, and real quick, just notice, I mean, for our original function f, what is it doing to the input? It's just doubling it. And the inverse is having its input. And well, that makes a lot of sense, right? What is the opposite operation, so to speak, or what's the inverse or the reverse operation of doubling? Well, it's having, and so this makes a lot of sense. Okay, so let's do the same kind of thing now for part B, right? So for our function g, the relationship between the input x and the output y is y equals x minus 4. And so for the inverse function, g inverse here, we just swap the roles of x and y. And so we get that. And so then I can solve here for y by just adding 4 to both sides. And I'm going to get that x plus 4 is equal to y. And again, I'll write my final answer in function notation. So g inverse of x is equal to x plus 4. And again, given that the original function g subtracts 4 from the input, it would make sense that the inverse is going to do the opposite operation. So in other words, it's going to add 4 to the input. All right, great. Next up we have part C. This is h of x is 2x minus 4. So for our function h, the output y is given by 2x minus 4. So then for the inverse here, we have that x is equal to 2y minus 4. So go ahead and add 4 to both sides. So we'll get x plus 4 is equal to 2y. And then go ahead and divide both sides by 2, and we'll get x plus 4 divided by 2 is equal to y. And so again, I'll go ahead and write the final answer in function notation. We're saying that h inverse of x is x plus 4 all divided by 2. Okay. So now here, real quick, note that if I input something into the original function h, the sequence of steps here would be to first double that input. You would do this part first, and then we're going to subtract 4 from that result, right? So you double first, and then you subtract 4. Okay, so how would I undo this process? Because that's really what the inverse is going to do. Okay, well, think about, I put my sock on first. That's like this first step here in blue. And then I put my shoe on second. If I want to undo that process, well, I have to take off my shoe, and then I have to take off my sock, right? So in other words, to undo a process like this, I want to do the opposite of each one of these operations and in their reverse order. So what's the opposite operation of subtracting 4? Oh, it's adding 4. So notice here what the inverse does is it adds 4 first. So I'll say this is 2 inverse, okay? So we're going to do that part first, and then what are we going to do? We're going to divide all of that by 2. This would be, well, the opposite of multiplying by 2. So what this function is doing is just simply doing the opposite of each one of these operations. So it's doing the opposite of the doubling, and it's doing the opposite of the subtracting of 4, and it's doing those in the reverse order, right? We're adding 4 and then dividing by 2. All right, so now let's check out D. Well, we solve this in just the same way as the others. We got that y is equal to 1/5 times x minus 4 plus 7. So then for our inverse, go ahead and swap our inputs and outputs. So swap x and y here. And then we get this. So let's now go ahead and subtract 7 from both sides. And I have that. Now I could distribute the 1/5, but actually a little simpler. I'm going to multiply both sides by 5. So here we're looking at 5 times the quantity, x minus 7, is equal to y minus 4. And then lastly, go ahead and add 4 to both sides. So you get 5 times x minus 7 plus 4, and that is our y. So written in function notation, we would say that f inverse of x is then 5 times the quantity x minus 7 plus 4. Okay. And again, kind of like we saw in part C here, what sequence of steps are we doing for capital F? Well, we would first subtract 4, then divide by 5, then add 7. What does the inverse do? It subtracts 7, multiplies by 5, and then adds 4. Oh, it's just doing the opposite of each operation you see for the original function and in their opposite orders. Okay, great. Part E, g of x is x squared, where x is greater than or equal to 0. Well, what I'm going to do first off to the side is just draw a little picture of the graph of g. And so g of x is x squared. That's just our standard parabola. But now since we're restricting x to be greater than or equal to 0, we're actually only going to get this right branch of the parabola. And notice that by making that restriction, since I'm only looking at this branch of the graph here in the first quadrant, this is 1-to-1. It does pass the horizontal line test. So g is a 1-to-1 function, so its inverse does exist, and we can find it in just the same way we've been doing these others. So here I'll say for g, we have that y is equal to x squared, and then for emphasis here I'll say that x is greater than or equal to 0. So then for the inverse, well, for that we want to reverse x and y, so it's going to give us x is y squared, and now this constraint that x is greater than or equal to 0 is going to become the constraint y is greater than or equal to 0. Okay, great. Now let's go ahead and take square roots of both sides to get rid of the square. And now you know that when you take a square root like this, we're going to get a plus or a minus. So here's what we're looking at. We have plus or minus the square root of x is equal to y, and we know that y has to be greater than or equal to 0. Well, if y has to be greater than or equal to 0, and y is either the positive square root of x or the negative square root of x, this right here tells us to choose the positive sign. So we're going to use that positive sign because I know that y cannot be negative here. So when all is said and done, I can write my answer as g inverse of x. That's equal to the positive square root of x. Okay, great. So that does it for A through E. And now if you look at parts F, G, and H, okay, these are all exponential functions, right, that we looked at the beginning of chapter 13. So for those, let's go ahead and investigate what we can do here. Well, we can go ahead and start out by just saying, well, for part F, we have our function h, and we have that y is 2 raised to the x power. And so then we could say that for the inverse function, we would then have that x is equal to 2 to the y power. And now the question is, how do you solve that equation for y? Well, how do you get something out of an exponent position, right? That's really what we ultimately need to do. And that's just not something we've encountered, at least in this class yet. And in fact, this is going to lead us to this idea of a logarithm. And logarithms are the subject of the next section, where we'll get into the details of logarithms in a lot more detail. But for right now, as a little preview, I'm just going to tell you that in order to solve an equation like this, okay, we have to use what's called a logarithm. It's really the definition of what a logarithm is. Okay, so here we're going to write this: y equals log, so that's log, it's just short for logarithm. And now the base of the exponential here is 2. And so what we call the base of the logarithm is also 2, and we write that as a little subscript of x. Okay, so to solve this equation for y, in other words, to get the y out of the exponent position, we have to use what's called a logarithm. And we can write the final answer there in function notation, and that would be h inverse of x would be log base 2 of x. Okay, so as I said, we will fill out a lot more details about logarithms and how they work in the next section. This is just a bit of a preview. Now the others are really going to work essentially just the same. So if I had the function w of x is 1/10 to the x power, this is exponential. Okay, skipping over some of the intermediate steps like I included above, the inverse here really by definition will be the log, and then the base of this exponential is 1/10, so that will be the base of the logarithm here. So the inverse function would be the log base 1/10 of x. And then lastly, we have p of x is pi to the x. That's another exponential function. And so its inverse will be a logarithm, and it will be log base pi of x. Okay, so in the next section, we will actually define logarithms and get into a lot more detail there, and I will see you there. Thanks so much.